Oops. Hi everyone, my name is Shakayla and I'm going to be talking about the carbon cycle in a more detailed way, going off of a article that I read, sort of like a review, but I'm also intermingling what we've learned in class. What do we know already? Carbon was first introduced on early Earth during its differentiation, in which our core was depleted of carbon and made its way up to the surface. When the Earth was young, about 2.4 to 2.3 million years ago, we started to see microscopic cyanobacteria that help facilitate photosynthesis. For a detailed description or definition of the carbon cycle, it is the biogeochemical cycle by which carbon is exchanged among the biosphere, pedosphere, geosphere, hydrosphere, and the atmosphere of the Earth. It is the main component of biological compounds as well as a major component of many minerals. The four major parts of the carbon cycle is photosynthesis, decomposition, respiration, and combustion. Now, I did read an article, as I stated before, to help me better explain the depth of the carbon cycle, and it presented two premises and two hypotheses. The first of the premise is carbon is delivered very inefficiently due to human choices, and we'll talk about that more later. And eroded carbon is being replaced, as in maybe it's being dependent on humans, which we'll also go into later. The two hypotheses that it presented was extra carbon is being buried due to human intervention, and soil formation is being replaced by new man-made soil. Now, within reading this article or articles I've read too, there were some very surprising things about the carbon cycle that I didn't know affected us as much, and it was actually pretty disheartening. We actually our exploitation of our soils and our other natural resources accelerates carbon usage. In a way, we make carbon through these fertilizers because we want to better our crops, but it's really damaging because the natural carbon that's being produced is still being buried. And actually, even the fertilizers that we've produced, there's only a very small fraction of that is actually being used by the plants as intended. In a lot of these areas, because of agriculture and how we farm and the areas we farm, a lot of the soils that we move out the way or we don't really need, we just push it out the way and it doesn't get washed off into a body of water like it should for the carbon cycle to naturally continue. And so the trapping efficiency is over 90% in the US alone, which is really, really high. I didn't expect the US to be that bad. Now, the article wanted to compare the pre-agriculture area of how much carbon is being produced then or trapped then to now, but there was no real way to measure that. So for now, it stated that maybe things haven't changed as much from now, so it's going to use the present values sort of as the past values to measure how much carbon is being produced and used and trapped. Now, there's three prominent areas where carbon is actually trapped. We have the lacustrine sediments, the colluvial sediments, and alluvium sediments. Smaller areas are eroding faster with no access to water compared to bigger locations, as I explained earlier. More than 90% of sediment eroded does not make it to a water source, particularly in the US. Too much additional carbon may be stored. So as we're making these fertilizers and producing this amount of carbon, it's not being used, but at the same time, as humans, we've grown to know and understand that. So we try to push for more carbon, though we know a lot of it is being stored. It's sort of a double-edged sword. I understand that we want to do better, but we're not. It doesn't seem, from the article's perspective, it doesn't seem that we're getting to the root of the issue. because we're still producing too much fertilizer and other processes that's not helping. Because even if, for example, we grab the soils that we're not using for agriculture and let's say we put it in the ocean or something like that, it's just too much at this point that even if we try to balance it out, like global warming will probably be inevitable. Like it'll probably get really hot really fast for a really long time. And this sucks for the farmers because it lengthens the growing season and increases soil evaporation rates and increases the likelihood of droughts and increases biological carbon sequestration and enhances the greenhouse effect, which is again just the human touch of the greenhouse effect that's already in place. It's just accelerated through human interaction. But to correct myself, it's too much additional man-made carbon that may be stored, which I also explained. Now, we have some graphs and tables here that I'm going to explain that I found, again, really surprising that I got from my articles. On the left, for table 2, I discovered that in the US, we don't have a lot of storage capacity compared to the 253 largest lakes in the world. But at the same time, we have I believe I calculated over 20,000 times more sediment than the 253 largest lakes in the world combined. And that blew my mind. That we have too much going on, right, in the US. And it made me think about, well, how much of the US alone is driving climate change? And yeah. And then in the top right equation is there to describe what the article tried to quantitatively calculate how much carbon is being used, or how much carbon, I should say, is being produced just from human interaction alone. The FT describes our prediction of the total amount of carbon in all the suspended sediments. We calculate this by subtracting the carbon weight fraction of the original sediment and derived sediment, which is F of C and F of V. And we multiply that by the constant aquatic concentration, which is described as SC. This equation is also known here as K, this part of the equation. We then divide that value by the total suspended sediment plus the carbon derived from human erosion of soils in that particular area, which is F of V. And on the bottom of that equation, we can see actual different environments and how that the carbon is being stored there. Here's a diagram of the carbon cycle, and it shows the 4 different components as measured as mentioned earlier in my presentation. So in conclusion, about anywhere between 0 to 2.3 times 10 to the 15th or 2 quadrillion, 300 trillion of carbon storage is a result alone of human-induced changes in the carbon cycle compared to the natural 8 billion. And that's over 200,000 times more storage. And as I brought up earlier, in the US alone, how much do we actually affect global warming? Here are the articles I used for my presentation. And thank you for your time.